We will work on phonetic indexing. So I'm going to take some example to make it clear. For example, if you take through in English and throat, you have like this similar pronouncing with the thorn, through and throat. Though if you take like treat, or you don't have something similar. And so like here it's not only the letters, it's a combination of letters that are making sounds, and sometimes, and I think English is a good example for that, oh, I have a warning from YouTube checking me, asking me to check the resolution, so I'm going to check the resolution. Sorry. Audio, video, base canvas, output canvas, scaled. I'm gonna try to remove the scale, so I'm gonna start the streaming here, and it should work if I'm lucky. Okay, lovely. So I think that right now you may have a better resolution while watching. So yeah, so we have this kind of problem, and basically, I think in English about half of the words have pronouncing that's different than what you could guess if you just know the rule of pronunciation in English, and that's why phonetic indexing help to transform things together. So we can give a look briefly on what exists around that, but first, what the applications there could be. First, like for example, maybe fixing spelling mistakes. So I don't know. Let's take an example of a word that often has a spelling mistake. Yeah, for example, if I say you are in French, it is vous êtes, which you can spell like this. Basically, you don't pronounce the last letter. Like this, which is a correct spelling. Like this, which is a fairly like alternate spelling too. Like this, like so you have a lot of different things, and if you are able to know that what your user typed is actually matching something of any relevancy in some words that you know that are correct, you can maybe suggest some typo fixes. You can also use this to do some fuzzing matching. So for example, if I have a social network and I have people registering with their names or pseudonyms, and there is this guy called Cool Kid, and I just remember his name, and I spell it Cool Kid because it sounds like more logic to me, and I don't find him, and that's kind of frustrating. And for that, like fuzzy matching could help. And we can also look, so I'm going to take notes about what looking. So existing algorithm for that is Soundex for English. We are going to use something called Kölner Phonetic for German, and we are going to try to adapt something of our own for French right now. French, like we need to find a name. I don't have a name for that, but it's not the most important thing. So yeah, and I wanted also to talk about edition distance / Levenstein. I think there is an S somewhere, but I'm not sure. So I should have cleared all this thing around. So let's first look at Soundex. I think the first result in Wikipedia will be right. So Soundex is a specific algorithm for phonetic indexing. And basically you have some rules like return the first letter of the name, and basically you drop all vowels plus some extra letters like H, M, W, and then you replace things by some digits. And what else? In the end, you truncate to keep only a few letters. So basically the first letter is always kept. So for example, we have examples here, Robert and Rupert. And you can see that here they both output the same index. And actually, like if I pronounce the words Robert and Rupert, I think that like the pronouncing is very similar. And basically here we encode that B and P are very similar sounds, and they are also close to V and F. So V and F is kind of understandable, B and P are two together, but like the whole mix, I think you have some people that know better about like phonetic theory than I do, and think that all those things should be aggregated together. So that's the algorithm for English. Then you have the Kölner phonetic. Yeah, that's it. You can read the page in English. Actually, we can open it as well. This is for German, and same thing. It outputs numbers here, and it has some different rules, like for example, if I have two consecutive 5, then I remove and keep only 1, and then I remove all the 0 digits, which here corresponds also to removing like most vowels plus extra letters. And here you can observe that you have a table that tells you that you substitute this for this, this for this, this for this. So you have a set of rules. And so we are going to review an implementation of this, and when I was implementing it, it was not very clear about in which order you should apply those rules. So it was kind of challenging, and I picked an order during the implementation, which is basically the one which is presented here, which follows like the numbers presented here too. And trying to also highlight that some things need to be like in the initial sound or some combination, and so you have to check first for a combination of letters and then for the individual letters, otherwise you break things, and we will review that when we discuss the German implementation. And so similarly, you have something called the I know there was an S, the Levenstein distance. And so basically, if you take two words, two string of characters, and you have this algorithm that detects how many addition and deletion and replacement should be done to transform a word into another. And for example, if I take this with cool kid and stuff, if I do an existing, a Levenstein distance between cool kid and cool kid, it will basically tell me that this word here is not very far from this word here, and like the distance can be done with one replacement. And this is a shorter distance, for example, as if there is something like that. Why? So this would be like two replacements. No, would be one deletion, one addition. And because I need to remove the C, and then I need to edit here. So this is something you can also use to check for typing mistakes. Though sometimes it is very, very irrelevant. And for example, like if French is a good example for that, because there are a lot of letters that you don't pronounce. For example, like they love each other is it's this is love, and this is like each other, like one another. But like you can make it's exactly the same. Like if you want to say that someone like a guy loves himself, you would spell it that way. And already the excitation distance is like quite different from what we used to see here. And if you include like spelling mistakes, for example, what like a kid could write is something like that. It's M, or it could also write something like this. And like the pronouncing is exactly the same between this and this and this and this, even though like this is not French at all. But the addition distance grade much bigger than if you just compare spelling mistakes that would look like, for example, this. So This is something that you should look at. You have like pretty cool implementation in PHP that you can check in documentation sites. And basically this implementation will return you only one integer, and this integer can be a string. Sorry, this integer is an integer, but this integer can be actually computed because you will define the cost in terms of how much it costs to insert a character, how much it costs to replace a character, and how much it costs to delete a character. So usually what I like to do is like one for each. Maybe, I don't know if I make maybe two for replacement, I'm not sure. But the important thing would be also to, if you use this, to take in consideration the length of a word. For example, if I take the word you in English, I'm going to kill that. You in English, and I make spelling mistake, like, you know, like goo. Here, like the algorithm, if I say like 111, it will tell me that there is one replacement. So like addition distance is 1. But if I type another word like immediate, and I make spelling mistake and I type a R or a D instead of the last E, addition distance is 1. So here, if I divide, the thing, what I want to highlight here is that here 1 is not a lot if I have a 9-character word, but over a 3 characters word, it's very different. So if you use this, I would suggest also to normalize. Normalizing would be to divide, divide by the number of characters. And also, if you have like 2 different words with different length, you of each word by the, so you would divide by the average of the number of characters of each word, which would like give you something where you would actually say, okay, like the distance between this and this is 1/3, and the distance between this and this is 1/9. So those are much closer than those. Okay. So we have already like spent quite some time on this. I'm just gonna take notes about how long it has been that the stream has been rolling, and if I can, yes. Okay. No, I can't get this information. It's unclear. Well, that's fine. I will survive with it. So we have reviewed what is the Soundex algorithm in English, what is it in German. We haven't critiqued them, but basically Soundex algorithm in English looks like something like that. And the results of the sound, like the Kölner phonetic, results in something like this. So you only have numbers, and actually you don't have repetition, so it looks like something like this. And I think you don't have 9. The problem with this is that like I have absolutely no idea about what those words were, and I think that something that is more readable would be interesting. And also, like, these algorithms are not generic, but considering that like different languages are pronounced with different rules, I would say that it's kind of normal. And we also have mentioned why we're doing this. So for fuzzy matching, to fix spelling mistakes, or to help you like look up people by names where spelling is often not standard. And maybe I didn't mention that, but for example, for poetry indexing, like if you are looking for a lot of repetition or similar words, like yeah, like B and P give more alliteration if you mix them in a sentence, like a lot of B followed by a lot of P, like it will keep some spirit. Something that will not happen if you are working on some with different letters. Like if you take a succession of B and then you have a succession of F, you will not get the same spirit. So here we are. I'm gonna start PHP